Today I'm going to be showing you how to reverse a singly linked list using an iterative method. So the way I'm going to be doing it is I'm going to be iterating through the list and reversing all of these links such as so that they point the other way. To do that, I'm going to be using three variables that each are going to be pointing to a node or the same node. So those variables are going to be called frontier, mechanic, and we're also going to have signpost. So the job of frontier is always to be at the front of the linked list as we iterate through it. So we're going to initialize it to head. The job of the mechanic is the one that actually reverses the links. So that's also going to be initialized to head. And signpost will be initialized to none or null, as it's none pretty much equivalent in Python. So the reason why signpost is none is because signpost tells mechanic where to actually reverse, where to point the link to. Instead of pointing to 7, for example, it's going to be pointed to null. And the reason why it has to be pointed to null is because this 3, while it's our first element, by the time we're done reversing the list, it's going to be our last element. And as you can see here, the last element always has a link that points to null. So let's actually begin to do this. To set up our loop, all we're going to do is just iterate while our frontier is not none. And then while that's true, we're going to be iterating through our linked list. So first, let's actually, we don't care about head anymore. We already, that's pretty much the name frontier now. So frontier is here. Mechanic is here. And currently our signpost, I'll just call it, write out the whole thing. Signpost is at null. So we have 3 steps. First, we want our frontier to move on to the front of our linked list, just one ahead of everything else. So frontier equals frontier.next. And that just moves our frontier from 3 to 7. So right now everything is kind of pointing to its own node, which is nice. Now we want to actually fix our link. So we want to set mechanic.next, so that's referring to the next node, and set it equal to signpost, which tells mechanic where to set its link. So that takes our current link and sets it to whatever node signpost is referring to, which is currently null. Now what we want to do is we actually want to move everything forward once, except for frontier. So as you can see here, currently frontier is disconnected from mechanic. So we always need to keep at least one reference on this separated linked list, because now we essentially have 2 linked lists, and we want to keep track of both of them. So we're going to move mechanic to frontier. So mechanic equals frontier. Oh, I'm sorry, before that, we want to move our signpost equal to mechanic. Because notice this link only goes one way now, so the only way for me to move signpost to mechanic is by setting it this way. There's no link. Actually, it doesn't even matter that there's a link because this is not even a node. So we're going to move signpost over to mechanic, like that. And then we want to update our mechanic to frontier. So mechanic equals frontier. And that's just taking this guy and moving him here. Oh, the H got a little chopped off on the I. Anyway, so now as you can see, we're on our second iteration. And this is pretty much all you need. So let's just run through it again and make sure that this makes sense. So first we move frontier to the next, just like we did before. Now all of them are on separate nodes. Then we get mechanic to repair the link. So mechanic.next equals signpost. And this no longer exists. And then we just move signpost over. If we move mechanic over first, mechanic to frontier, that won't work because then we've lost essentially every reference to the 7 because this is only a one-way link, so we can never get signpost to the next node. So first we have to move over mechanic. I just did exactly what you shouldn't do. First we move over signpost, and then we move over mechanic. So let's just run through this a couple more times. Frontier is equal to frontier next, so frontier is null now. Mechanic.next equals signpost. And remove this. Signpost equals mechanic. And here, you could put a check here. If frontier equals null, we can return either signpost or mechanic, but it's easier to just kind of keep doing what we've been doing so far and move mechanic over. And now we just return signpost. And as you can see, now our list has been reversed. Before it was 3, 7, 10 null. Now it's 10, 7, 3 null. So let's actually try it out. So we have our head. So we're going to make 3 list nodes. We're going to make, so we're going to initialize frontier equals head, mechanic equals head, and then signpost equals none, just like we did over here. Now, while frontier is not none, frontier equals frontier.next, mechanic.next equals signpost, signpost equals mechanic, right? And mechanic equals frontier. And then we just return our signpost. And this should work. So let's try it out. And there you go, accepted. So I hope that, wow, beats 5.2%, great. I hope that kind of helped clarify the way this worked because it can be a bit confusing as to why you actually need 3 references to the nodes, but all of them are pretty necessary. If you know of a way to do it with 2, then just comment below. But that's all for now. Thanks and bye.